Okay, today's lesson will be on exploring real numbers. In your textbook, will be on page 17. Your note sheet should look like this, and you will see page 17. We're going to work through on the Smartboard and Smart Notebook. First thing we need to do is we've got some vocabulary words that we're going to need to define. We'll see natural numbers, whole numbers, and integers on your definition sheet. Natural numbers are really just counting numbers. Whole numbers, I'm going to tell you, are counting numbers. So you might say, what is the real difference between whole numbers and counting numbers? There are mathematicians out there who will say that natural numbers are 1, 2, 3, and so on, where whole numbers will include 0 in that sequence of numbers. There is no set guideline as to whether natural numbers include 0 or not. There's still debates out there. But as far as your book is concerned, your book considers counting numbers as numbers 1, 2, and so on, and whole numbers including 0. Integers. Integers we talked about last year as well. Integers are whole numbers and their opposites. Whole numbers and their opposites. So for every whole number you have, with the exception of 0, 0 is neither positive nor negative. So if you have 1, then you have negative 1. If you have 14, then you have negative 14. If you have negative 6, then you have 6. Integers, whole numbers, and their opposites. Rational numbers. Rational numbers are in the middle of page 17. It's any number that you can write in fraction form. Where you have A over B. B, however, cannot be 0. If B were 0, then we might have an irrational number. Irrational numbers are written as fraction as well, but A and B can be integers. And that is in the middle of page 18. So I want us to look at in summary here. In summary, you have a little chart where we have real numbers. Okay? And we have two categories in real numbers. They are rational and irrational numbers. Okay? Within the rational category, we have two other categories. You have integers and whole numbers. If you would like, you could put some examples. This chart is duplicated on page 18 in your textbook. So for rational numbers, we have 5/8 would be a rational number. 25/100 would be a rational number. 3/10 repeating would be a rational number. 1/2 is a rational number. Integer, -3, 4, 7, -12. Whole numbers, you know what those are. Notice, though, that we have whole numbers inside the integers. That means whole numbers can also be integers. We have integers inside the rational numbers. Integers can also be rational numbers. If it is outside of the circle, like these, they are not 2500ths. It's not a whole number or an integer, but yet it's still a rational number. Irrational numbers. Very famous one, pi. There are other examples. In irrational numbers, decimals do not repeat. You are not able to get a whole number or an integer as a result. They are irrational numbers. In your textbook, it talks about counterexamples. You'll remember from last year we talked about counterexamples being when you can prove something wrong. You can prove that a whole number could also be an irrational number, then that would be a counterexample to having the two different. Inequalities and absolute value, reviews from last year. Inequalities are ways that we compare numbers. This is on page 19. In your note sheet, I have that it might be helpful for you to draw a number line. Using the number line is very helpful when you compare integers. Notice that absolute value, remember that's the distance from 0. We look at our notes, inequality signs are less than, greater than, less than or equal to, or greater than or equal to. Those are the most common ones. Absolute value, the absolute value of -7. -7 is how far from 0 on the number line. It is 7 units. So the absolute value of -7 would equal 7. That takes care of the first lesson. Notice that I have asked for you to do some practice problems and the quick checks on pages 17 to 20. We're going to move on, however, and talk about lesson 1-4, which begins on page 27. We're going to talk about functions. Remember last year we ended the year talking about functions. We're comparing two things. These are two separate charts here. Chart number 1 is starred in red. Chart number 2 is starred in green. If you look at your note sheet, you have this chart. Number of loads compared to cost. We're doing laundry. One load of laundry is going to cost me $2.75. 2 loads of laundry is going to cost me $5.50. 3 loads of laundry, $8.25. 4 loads of laundry, $11. At the very top of your note sheet, it says, when you are looking at a function and determining the function rule, first begin looking for a common difference between 1 to 2, that is a difference of 1. 2 to 3, a difference of 1. 3 to 4, a difference of 1. So let's look from 275, from $2.75, $2.75 to $5.50 is how much? $2.75. From $5.50 to $8.25, $2.75. From $8.25 to $11, it's $2.75. My common difference is $2.75. That $2.75 is going to become my coefficient. That means I'm going to take the number of loads times 275, and that's going to give me my rule. So the cost will equal $2.75 times the number of loads. I'm going to use L for loads. Is that true? If I take 1 times 275, do I get 275? Yes. If I take 2 times 275, do I get $5.50? If I take 3 times 275, will I get $8.25? If I take 4 times 275, will I get $11? Yes. Let's look at the hours versus the miles. You take a minute and compare the difference between 60 and 120, 120 and 180, 180 and 240. What did you come up with? The common difference? $60. Then 60 becomes my coefficient. So my function rule. The hours, sorry, not hours. The miles driven is going to equal 60 times the number of hours that I drove. Let's double check. 1 times 60, is that 60? 2 times 60, is that 120? 3 times 60, 4 times 60. Looks like it worked for every time. Continuing in the lesson on page 28, this is more for a challenge. You're going to be looking at variables and domain and range. You need to know what domain and range are. Domain is the values for input, and range are going to be the values for output. There is a Khan Academy video listed on this as well that you can look at to challenge yourself when you're looking at domain and range. Please make sure you complete all the practice problems. Any problems that were not done together, which I believe you still need to complete the function and function rule for number of houses and number of toothpicks, and then you will be done with today's assignment. You're not ready to go for class tomorrow.